Okay, so this next lecture for Unit 11 is on the pH scale, and you're going to want a calculator and a periodic table. Okay, without a calculator handy, you're really not going to know what to do because for most of the questions I gave you the answer. Learning how to do pH is pretty easy. The hard part is just knowing what buttons to push on your particular calculator. So what we're going to look at today is what pH stands for, and we want to be able to calculate pH and pOH and be able to calculate the hydrogen ion and hydroxide ion concentration. I get a little typo there from the pH and the pOH. So what pH stands for is powers of hydrogen. It is a logarithmic scale. So it's based around these powers of 10. And the pH is, the P is for power and the H is for hydrogen. So if I am looking at something like pOH, then I am talking about powers of hydroxide because that's what the OH stands for. Now, the pH scale goes from 0 to 14. And in reality, it does go less than 0, and it is greater than 14, but not for what we do. Most things on the pH scale are between 0 and 14, and that's where I keep it for our assignment. pH 0 is very acidic, 14 is extremely basic, and then pH 7 is neutral, which is water under certain conditions. It all depends on where you're getting your water and what it's doing. Okay, so down here are several formulas. And so these formulas are provided to you on your assignments, and that's what we're going to be using today. Now, one key we haven't used this year in chemistry is the log key. So it's really important to find the log key on your calculator. So we've got these square brackets, and these square brackets are actually an abbreviation in chemistry. Those square brackets mean concentration of. So the square brackets mean concentration of hydrogen ions. And as we just recently learned in our last unit, concentration is measured in molarity or in moles per liter. And you're going to have to be able to do moles per liter calculations in order to do these pH calculations. The two concepts are related. So here we go. Hydrogen ion concentration of a solution is 1 times 10 to the negative 10th moles per liter. What's the pH of the solution? Now, this all depends on your calculator. Okay, some of you are going to have to write it one way and some another way. Let me see here. Okay, so here's 2 ways to go about it. If you've got a big Texas Instruments with a screen, you want to do negative log 1 and then your exponent key, which if you're using the big TIs, it's usually the EE, and then negative 10. And that should get you 10 as your answer. Some of you can't hit the negative key first, and you're just going to have to do log and then 1 and whatever you use for your exponent key, negative 10. And that's going to get you negative 10, but you have to then take the opposite of it because you didn't use that negative sign right there, and then make that, whoops, make that 10. Not negative 10. Whoops, erase, erase. We can erase that right there. Okay, so that's going to make it 10 at that point. Some of you have calculators that I think work kind of backwards. You are going to have to do 1, whatever your exponent key is, negative 10, and then you are going to have to hit your log key. And then at that point, you're going to get negative 10, and you've got to do the same and turn it into a positive. So this is the challenging thing, is just figuring out your calculator and how to use it. Okay, so it's playing with it. So here on this slide here, I just give you 4 examples, and I want you to just play with it in your calculator. Make sure you can get the examples. Make sure you also get the answers filled in on your notes. Okay, so type in the numbers, hit log, and then take the opposite. Change the negative to the positive. So again, some of you are going to have to hit your logarithm key first. Some of you are going to have to hit it second. if you can't get it to work, just bring your calculator to me in class and I will show you how to use it. Okay, so let's make sure you're getting those same answers. Now, we want to be able to work backwards. You want to be able to take the anti-log. The anti-log is right above your log key. So you've got your log key, and usually right above, and this is true for every calculator except for one I've ever seen, it says 10x. And this 10x there at the top is the anti-log. That's what you're going to be looking for. So if we want to work backwards, okay, the pH of a solution is 6. Find the hydrogen ion concentration for this solution. So what many of you have to do is hit your second key or your shift key, then hit your log button, okay? And then you want to put in pH, but look right there. I've got a negative sign on that pH. So that pH I need to make negative. So negative 6.0 and then hit equals. Okay? And you should get 1 times 10 to the negative 6th. So it says here, make sure you put the answer in scientific notation with proper sig figs. Okay, I'm actually going to change that sig fig thing, and I just want you to do 2 spots after the decimal. I know I didn't have it on my other examples, but that's how I want you to do it on your worksheets and how you're going to do it on your test. And the reason is logarithms actually have different significant figure rules. And I'm not going to teach you the other significant figure rules. Some of you are having a hard enough time with the first ones. Okay, so we would just write our answer as 1.00 times 10 to the negative 6 because I want 2 spots after the decimal, and I need my units, which is molarity. Okay, or you can use moles per liter. So that right there is your answer for that. So just like before, here's a couple to practice. So you want to take the anti-log, which remember the anti-log is looking for that 10x key. Okay, and don't forget to put in that negative sign with your pH. So just like before, write down these numbers. If you're having difficulty getting them on your calculator, bring your calculator to me and we'll make sure that you can solve them. Okay, so let's try a couple of other sample problems. If the pH equals 11.5, or sorry, if the pOH equals 11.5, what is the pH? Is this an acid or a base? Well, I gave you a couple of formulas on the earlier slide. I gave you log of hydrogen ion concentration equals the pH. I also gave you pH plus pOH equals 14. Well, I'm given the pOH right here. pOH is equal to 11.5. So here I can plug that in. So pH plus pOH is 11.5 equals 14. So that means my pH would equal, doing the math in my head here real quick, 2.5. And then the question is it an acid or a base? Well, since the pH is equal to, or I should say the pH is less than 7, it's an acid. Okay? Very important. Only determine if it's an acid or base by looking at the pH. Only determine if it's an acid or base looking at the pH. If you look at the pOH, you'll get the opposite answer, and it'll be wrong. The follow-up question is, what's the hydrogen ion concentration? Well, that's what we just practiced on the last slide. If I want to get the hydrogen ion concentration, I do 10 to the negative pH. And that's going to give me my hydrogen ion concentration. So I would do 10 to the negative 2.5. So again, you're using that anti-log. You want to use that 10x key. And if you do that, and work this one out in advance, what you get is 0.003162 and some more numbers, okay? I want you to keep the non-zero numbers past the decimal because we want the first two sig figs. So I'm going to keep these numbers right here. So 0.003, it's a 1. After the 1, I look to the next number. It's a 6. That rounds up. So 0.0032. My units for concentration are molarity. And that's my answer. Okay. Okay. In this next one, what if the hydroxide ion concentration is 6 times 10 to the negative fourth moles per liter? What is the pH of the solution? Is it an acid or a base? So right here, I'm being tricky. I'm giving you the hydroxide ion concentration. Okay, so you got to pay attention to that. And I know I was a little tricky like that on one or two of them on your worksheet. So remember, moles per liter, that's the same as molarity. So my hydroxide ion concentration is equal to 6.25 times 10 to the negative fourth molar. I can get my pOH. pOH is equal to the negative log of the hydroxide ion concentration. And again, you don't have to memorize these formulas. They're going to be provided to you. So if I do that, I get a pOH is equal to 3.20. Okay? And that's after I round to 2 spots to the decimal. My pOH is equal to 3.20. Well, the question doesn't ask for pOH, it asks for pH. So I need to do the pH plus pOH is equal to 14. If I substitute in my pOH and I solve for my pH, I get my pH is equal to 10.8. And then I'm asked if it's an acid or a base. I can look at my pH and the 10.8 is greater than 7. Therefore, it is a base. And there's my answer for that one. Okay, so a couple extra steps. You got to pay attention closely whether or not it's asking or giving you the hydrogen ion concentration or the hydroxide ion concentration. We're going to do one more here. What's the pH of a solution that has 5.55 grams of hydrobromic dissolved in 155 milliliters of water? Well, in order to do pH, pH is equal to the negative log of the hydrogen ion concentration. I don't have the hydrogen ion concentration. In fact, I don't have any concentration at all. So what I need to do is I need to solve for the concentration. Molarity, concentration, is equal to moles over liters. Well, I don't quite have moles either. I've got grams and I have milliliters. Okay? So I'm going to have to do a little bit of stoichiometry in order to figure out my moles and some conversions to get my liters. So I've got 5.55 grams of HBr. Oops, there we go. Diagonal down, I have the same units, grams of HBr to moles of HBr. I relate everything back to 1 mole. I add up grams off the periodic table. When I add up grams off the periodic table for the hydrogen and the bromine, I get 80.91. I do my math, and what you should get is 0.068594, etc., etc., etc. Okay? Don't clear your calculator. Just leave that the way it is, and that is moles. Now, I've got my liters, and here I have milliliters. You need to be able to change your milliliters to liters. That should be automatic to you at this point. We've done it in units 10 and 11. So 155 milliliters is the same as 0.155 liters. Okay. So I can just take that number on my calculator, hit divide, and get 0.1, hit divide, and do 0.155. And with that, I get this other long number, 0.4425, etc. And that is my molarity. Okay? So now I actually have a concentration. When I put this hydrogen bromide in solution, it's going to split up into H plus ions and Br minus ions. And so when I figure out this concentration, that's my concentration of hydrogen ions. It also happens to be my concentration of bromide ions. We just don't care. So now I can take that number and do the negative log of 0.4425, etc. Just use all the numbers on your calculator and hit equals. And at that point, I get 0.3549 and some more numbers. And right now, I'm just telling you guys to round to 2 spots after the decimal, 2 sig figs after the decimal. And so that's going to give us a pH equal to 0.035. So this is extremely acidic because it's real close to pH 0. Okay? So you are going to have a couple of these problems to do. Not too many. You have your worksheet emailed to you already. Some of them you need to show your work and some of them you don't. So for the ones you need to show your work, you can insert a picture using your web camera or with a whiteboard or notebook paper. So again, if you're having trouble doing logs on your calculator, please see me. Bring me the calculator and I am more than happy to show you how to operate it for logarithms.